All right, so today we're going to take a look at confidence intervals, and there are two types of confidence intervals we're looking at. We're looking at confidence intervals about a population proportion, right? And we're also going to look at the confidence interval as it relates to the population mean. Okay, so we're going to start off by talking about just the notations for a proportion, and then we're going to talk about critical values and setting up confidence intervals. We're going to calculate the confidence interval by hand. Okay, we'll do one of them by hand, and then we'll calculate the confidence intervals using the calculator. All right, so first we're going to start off with the notations for proportions. And a proportion is basically another name for a fraction, right? A part over the whole. So P is the population proportion. That's a notation. We also have what is called P hat. P hat is the sample proportion. The formula for P hat is X over N, where X is the number of successes and N is the sample size. Okay, so we saw that when we were looking at the binomial distribution. It kind of sort of, we were given a decimal or a percentage or a fraction or a proportion, right, which you can interchange, okay, any one of those. So we're given P hat is X over N. X is the number of successes. N is the sample size. You can also calculate Q hat, right? Q hat is 1 minus P hat. And Q hat is the sample proportion of failures in a sample of size N. Okay. So the P and the Q are somewhat familiar, but we're not using them necessarily in a binomial distribution. Okay. So P is a population proportion. That's the true population proportion. P hat is a sample proportion, and Q hat, well, P hat is a sample proportion of successes, and Q hat is a sample proportion of failures. Okay. Now here's some definitions. The first definition is called a point estimate. And a point estimate is a single value or point used to approximate a population parameter. So for example, as far as the population proportions are concerned, we're going to determine if a sample proportion is a good estimate or approximation of a population proportion. Okay, so we're going to be given a proportion from a sample. We're going to develop a confidence interval to see if that proportion, the sample proportion, represents the population proportion. We're also going to do the same thing for means. If a sample mean is a good estimate for a population mean. Okay, so we're using samples to make inferences about a population. The last sentence on the slide, we use P hat as a point estimate of P because it's unbiased. Okay, so P hat, we're using that as an unbiased estimate of the population proportion. Now, why do we need confidence intervals? In the preceding example, we saw that the best estimate of the population proportion P, but we have no indication on just how good that estimate is. So we give a range of where that population parameter can be found. Okay. We can't be exact, but we can give a range of values. That range of values is our confidence interval. Okay. So we can't specifically say that this proportion represents a proportion of the population, but we can give a range. okay, with a certain confidence that the population or that the sample estimate represents the population estimate. Okay. Some more definitions. A confidence interval is a range of values used to estimate the true value of a population parameter. A confidence interval is sometimes abbreviated as CI. So we're going to find confidence intervals for the population parameters, and those parameters are proportions and means. Okay, so we're going to look at this in a twofold manner. The confidence level is the probability of 1 minus alpha. That is the proportion of times that the confidence interval actually does contain the population parameter, assuming that the estimation process is repeated a large number of times. So the confidence level is 1 minus alpha. Okay, so we're going to actually see an example of what alpha is and what confidence levels are. Okay, now when we're setting up the confidence interval, we're going to need a critical value. The critical values can be found in one of two ways. They can be found using the calculator, and there are some other standard critical values that are just facts without you actually looking them up on the calculator. They're the critical values that are commonly used. The critical value is the number on the borderline that separates sample statistics that are likely to occur from those that are unlikely to occur. The number alpha over 2 is a critical value that a z-score, so we talked about z-scores in an earlier module, with the property that separates an area of alpha over 2 in the right of the standard normal distribution. So here's an example of, well, a picture of more or less what's going on. Let me just bring up one note. And that's just starting the page. All right, so this is critical values. All right. And we have the standard normal curve, okay, because we're referring to z-scores. All right, so 1 minus the confidence level is equal to alpha. So 1 minus alpha, okay, that gives us this portion as alpha over 2, and this portion as alpha over 2. So we're talking about critical values. So here we have the confidence level. We have the alpha. We have alpha over 2. And we have our critical value. Okay, so these are some standard confidence levels and critical values. All right, so, and these are some standard ones you're going to encounter. If you have a 90% confidence level, in order to find the value for alpha, right, we're going to subtract 1 minus the confidence level. So if I have 1 minus the confidence level, which is 90%, right, and 90% as a decimal is 0.9, my alpha is 0.1. To find alpha over 2, so it's like what we're actually doing is the critical values, those are going to be the z-scores located at this point and at this point. Right? So when we construct our confidence interval uses these critical values under the normal curve, and they give us our cutoff points. Okay? The value where the population parameter is likely to occur, and it separates the part of the curve that the population parameter is not likely to occur. So it's like a borderline value. Right? So you have to be given a confidence level. To find the alpha level, it's 1 minus the confidence level. We have to split our alpha in 2, right? Because we have 2 critical values. So if I have 0.1, which is alpha, divided by 2, I get 0.05. And the critical value for 0.05 is 1.645. So what all this boils down to, if you're asked to find a confidence interval with 90% confidence, your critical value is 1.645.
Wait, how did you find the 1.6? Sorry, I had looked away.
That's with the inverse normal. Like, these are just some standard things, but this is how you would find this in the calculator. If you were finding a confidence interval with 90% confidence, right, first off, I have to find alpha, so it's going to be 1 minus 0.9, which is 90%, so I get 0.1. I want the alpha over 2 value, right, because this is actually split up into 2 regions. So I'm going to take 0.1, I'm going to divide that by 2, and I get 0.05. Now I'm going to go into the inverse normal, and if I put in 0.05, I get negative 1.645. This is the reason why I get negative 1.645, is because the inverse normal, it calculates to the right. So even though I get something negative, I'm going to use its positive representative. Right? So that's why when you put it in your calculator, you get negative. But if I were to like calculate the critical value for the upper end of this, I would get something positive. So I could actually find an inverse normal for 1 minus 0.05, and I get the positive 1.645. These are the two numbers, right? I have negative 1.645. I have positive 1.645, right? These are the two critical values that gives us a 90% confidence. So even though when you initially put it in, you get something negative, when we perform our calculations, we're going to use a positive, right? For a 95% confidence level, the critical value should be 1.96. For a 98% confidence level, we should have 2.326. And for a 99% confidence level, our critical value should be 2.576. And these are standard confidence levels and the standard critical values. So if you're given a 90, 95, 98, 99% confidence level, you can use these critical values without using the calculator. So if I kind of write everything in, alpha would be 5%. You split that in half, that's 2.5%. And then if you take the inverse normal for 0.025, that would give you 1.96. For a 98% confidence level, the alpha is 2%. If we split 2% in half, we have 1%. And if we put 1% in, so remember you have to move your decimal, I'm just writing in percents. We take the inverse normal of 1%, we get 2.326. And for a confidence level of 99%, alpha would be 1%. Alpha over 2 is 0.5%. And then we have the critical value as 2.576. Okay, so these are standard confidence levels and standard critical values. I don't think anything was asked outside of these critical values. Okay, but we will calculate one that is not common. All right, so here's just an example. Find a critical value I'm sorry. That was the wrong one. For a confidence level of 88%, find the critical value. Because sometimes you may be given confidence levels that are not those common 90, 95, 98, and 99. Here we want to calculate the critical value for a confidence level of 88%. So here's the steps. And we're basically going to use what's in this chart. So our confidence level is 88%. So the first thing we want to do is find alpha. So alpha is going to be 1 minus the confidence level. So alpha is equal to 1 minus the confidence level. And the confidence level is 0.88, right? So I'm just going to substitute the confidence level for 0.88. So alpha is equal to 1 minus 0.88. So 1 minus 0.88 gives us 0.12, right? So that's the first thing you do is find alpha by using that formula. Alpha is 1 minus the confidence level. The second thing we have to do is find alpha over 2, right? Because in our standard normal curve, right, we split that alpha in half, so we have a lower and an upper. So alpha over 2, that equal to 0.12 divided by 2, which is 0.6. So I have 1 minus 0.88. I'm going to divide that by 2, and I get 0.06. Right, which was our third step here in the chart. I don't know if you can see that, but that's what we're doing here. And then the last thing we're going to do is we're going to put that alpha over 2 value into the inverse norm. Use alpha over 2 in the inverse normal function. And change its sign. So we have inverse normal 0.06. So we have a critical value of 1.55. So now if we're using a common confidence level, we don't have to go through all of these steps. Okay? But if you're given a confidence level outside of one of the commonly used confidence levels, this is the process you would go through. All right, so any questions about critical values? Now, this is how the critical value plays a part in confidence level. All right, so this says find a critical value, Z alpha over 2 corresponding to a 95% confidence level. So since 95% confidence level is common, right, we don't have to go through all of the calculator steps. You can just refer back to this, right? So the critical value for a confidence level of 95% should be 1.96. All right, so this is a question that was actually on the handout. All right, now we're going to talk about a margin of error. So a margin of error is the maximum likely difference between the observed sample statistic and the true value of the population parameter. And usually they'll give like what a margin of error is in like layman terms is, just say like for the weather. Weatherman, they can predict the weather, but they give themselves some cushion just in case they're wrong. I guess that's what you say. So let's say like today is, what's the temperature for today? 78. And then they'll give you like a plus or minus 3 degrees. That plus or minus is like a margin of error. So it might not be exactly 78, might be 76, might be 79, might be 80. That plus or minus is the margin of error. The same margin of error is in our confidence interval calculation because we estimate a population parameter and then we give like a plus or minus, right? That plus or minus is the cushion or the confidence level of which our population parameter lies. So this is the margin of error. E, right, and E is a mathematical symbol for margin of error. That's equal to Z alpha over 2, and Z alpha over 2 is your critical value, times the square root of P hat times Q hat divided by N. So P hat is the sample proportion of successes. Q hat is the sample proportion of failures. N is the sample size. And Z alpha over 2 is our critical value. We put all of this together and this gives us our confidence interval for a population proportion. That's P hat minus E, right? And E is a margin of error. It's less than P, so P is the true population proportion. That's less than P hat plus E, right? So that margin of error, that's our plus or our minus that's attached to our proportion, sample proportion. All right, so let's take a look at this in an actual example. Okay, so we're going to do this two ways. We're going to do it by hand. Then we're going to use the calculator. And I believe there's a problem that's on the handout. We'll do that by hand and by using the calculator as well. All right, so this says a poll of 503 potential voters finds that 301 intend to vote for a particular candidate. Construct a 98% confidence level for the true proportion of votes the candidate will receive. Round your answers to 4 decimals. So again, we have a poll of 503 potential voters. And out of those 503 potential voters, 301 intend to vote for a particular candidate. They want us to construct a 98% confidence for the true proportion, for the true population proportion of votes that the candidate will receive. All right, so this is where we're headed. We're going to take that information and we're going to set it up by using a confidence interval. Should I copy this? And let me just make a copy of it real quick so I can write on it. All right, so let's construct the 98% confidence interval. So the first thing we're going to do is we're going to find p hat. Right. So now there was a formula to find p hat. P hat was equal to x over n. Right. So what is x and what is n? Well, n is going to be the sample size. So the sample size here would be 503, right? Because there are 503 potential voters. And x is going to be the number of successes. So out of that 503 people, out of the 503 potential voters, 301 intend to vote for a particular candidate. So x is going to equal to 301. Right? Those are the number of people that are going to vote for a particular candidate. So p hat is equal to 301 divided by 503. So 301 divided by 503 is 0.5984. So that's the first thing. Let's find p hat, because we're going to need p hat in our calculation. The second thing we're going to do is find q hat. So there was a formula for q hat. It equal to 1 minus p hat. Right? So remember that p hat is just an unbiased estimate of the true population proportion. All right, so we just calculated p hat. So p hat was 0.5984. So q hat is going to equal to 1 minus . So now mathematically, you should only round your final answer. So what I'm doing with the calculator is, even though on the screen I have 0.5984, in my calculator, I'm using the true value for p hat, including all of its digits. Because if we round, and then if we put this in the calculator is not going to round until the final answer. Well, it never rounds unless you force it to round. All right, so I'm using this true value for p hat, and q hat is 0.5984. So q hat is 0.4016. So I'm actually going to store some values. Okay, I'm gonna go back And I'm going to do this again. I'm going to store these values in the calculator. So I'm going to just clear everything out. So I have 301 divided by 503. I'm going to store that for P. So if you hit the STO, that's the store, that's short for store. I'm going to find P, and it's green, and it's above 8, so I'm going to hit alpha and 8. I'm going to store Q. So I'm going to put in 1 minus answer. So what answer is the previous result, which is the 0.5984 in its entirety. I'm going to store that for Q. Q is above 9 and Q is green, so I'm going to hit alpha and 9, and that's Q. All right, so I have rounded values on the screen, but in the calculator I have the true values. All right, so P is P hat, Q is Q hat. All right. So if we go back to our formula for just a second, we have P hat, right? We calculated that as 0.598. We calculated Q hat. The next thing we're going to do is we're going to calculate the Z critical value. So we have a 98% confidence level. And what's the critical value for a 98% confidence level? It should be 2.326. And I have lost. Maybe I should start a new page. Okay. So the third thing is we're going to find the critical value for a 98% confidence level, and that was 2.326. All right, so we calculated the confidence, or the critical value, just based on that 98% confidence level, right, which is a commonly used confidence level. All right, so that critical value of 2.326 is standard. The next thing we're going to do is we're going to calculate the square root of, we're going to calculate E actually, where we're going to take Z alpha over 2, we're going to multiply that by P hat times Q hat divided by N. So we're going to calculate E. Which is the margin of error. I'm going to just abbreviate that, M dot O dot E dot. So this is equal to Z alpha over 2 times the square root of P hat times Q hat divided by N. So Z alpha over 2 is equal to 2.326. P hat is equal to 0.598. Q hat is equal to 0.401. And N is 503. So now when we put all of this stuff together, we should have 2.326 times the square root of 0.598 times 0.401 divided by 503. So this is one of the reasons why I stored everything in my calculator. So we have 2.326 times the square root. So I didn't really have to put times in there because the calculator kind of understands that that's multiplication. P hat, which we stored for P, so I'm just going to recall P, times Q hat, we stored that for Q, divided by 503. And I want to close off my square root. And we have a margin of error of 0.0508. I'm going to take that 0.0508 and I'm going to store that for E. So E is above the sine function, so I'm going to store that for E. So we found the margin of error. So now we're going to put all of this stuff together. So if I go back to just the formulation for a minute. So this is the fifth step, is to construct the 98% confidence interval. Right, we have P hat minus E is greater than P is less than P hat plus E. So we're just going to substitute in P hat E, right, plus or minus. So this is P hat minus E and P hat plus E. So I have P and E stored in the calculator. So for the lower part of my confidence interval, I'm going to have P minus E. And I get 0.5476. And if we take P plus E, we get 0.6493. And that's our 98% confidence interval. So remember that this confidence interval gives us the interval for the percentage of voters that are going to vote for a particular candidate. All right. Any questions about that example? Now we're going to use a calculator. You can see how much easier the calculator is, but the way that some of the questions are set up, on some of the questions, they want you to find simply the margin of error. And that's one thing that the calculator won't give you. It'll give you the confidence interval, but it won't give you the margin of error. Okay, so calculating this fourth step, okay, is sometimes the only thing they want. Right? So now this is how you use the calculator. We want to use, I'm going to go in statistics or stat. I want to scroll over to tests, and I want to scroll down to, now there's a lot of stuff in here. I want to scroll down to one prop Z interval. That's one proportion Z interval. I'm going to hit enter. And then it's only going to ask us for three things. It's going to ask us for X. It's going to ask us for N. And it's going to ask us for the confidence level. All right, so our X value was what? 301, right? Because there was 301 voters that are going to vote for a particular candidate. N is the sample size. There were potential 503 voters. The confidence level is 98%. So 98% as a decimal is 0.98. And we hit calculate. I mean, that's a lot easier than what we just did. But notice the printout. It gives you the interval, right? 0.5476, exactly the same thing we got, to 0.6493. It gives you p hat and it gives you n, but it does not give you the margin of error. It doesn't show all of that. You got an 84. What is the show of yours? Did you go into stat, test, 80?
Oh, there it is. Okay. I just hit enter again.
Everybody else can use that on their calculator? All right, now there is a question on the handout. It's like on the handout, there are only like 2 questions. The first question deals with means, which we're going to talk about in the next class. And then the second question is actually the question that we just answered. Right. So let's pull up some homework problems. All right, question number 1, it says for a confidence level of 98%, find the critical value. Round your answer to 2 decimal places. So that 98%, didn't we just use that one? That's a common one, right? So that's going to be the 2.33. They rounded at the 2 decimal places. Now, if it was something other than a common one, right, we could calculate it. The second one says for a confidence level of 90%, find the critical Z value around the 2 decimal places. that was also a common one, right? Which was 1.64. So normally when they ask you for a confidence interval or give you a confidence level and want you to find a critical value, normally it's one of those commonly used confidence levels. Okay. I'm going to scroll down and let's look at problem number 4. It says express the confidence interval 84.4% plus or minus 3.1, bless you, 3.1% in interval form, and they're asking us to round to 3 decimal places and not use percentages. All right, and again, this is problem number 4. So how are we going to construct the confidence interval? They give us 84.4%, which would be the p-hat value, plus or minus, and they give us 3.1%, and that 3.1%, that's our margin of error, right? That whenever you see that plus or minus, the number that comes after that, that's your margin of error, and they want us to construct the confidence interval. So we can use this, right? We can take p-hat minus the margin of error and p-hat plus the margin of error, and that would give us our confidence interval. So that's 84.4%. Let me just write this down. 84.4% plus or minus 3.1%. And this was number 4. So that was 84.4% plus or minus 3.1%. And they want us to use decimals, not percentages. So I'm going to just convert these to decimals. So I'm going to move that decimal 2 places to the left and remove the percent symbol. So this is 0.844 plus or minus. So here again, I'm going to move this decimal 2 places to the left. So that's 0.031. And if I put this in the calculator, 0.844 minus 0.031, I get 0.813. I'm going to put in 0.844 plus 0.031, and we get 0.875. All right, so they didn't give us a confidence level because they gave us the p-hat value and they gave us the margin of error. And within this margin of error calculation, that Z critical score has already been added. So normally they'll say a 90% confidence level. Here they didn't give a level because that level was actually calculated within that margin of error. So for this example, we get 0.813 to 0.875. Okay, now there are some questions that, for example, number 5, it says express the confidence level. We have 24.2% and 42%. So that is the confidence level, the confidence interval. They want us to express it in the form of p hat plus or minus the margin of error. So I'm actually going to copy this over. This was number 4. This was number 5. All right, so this is number 5. Okay, so it says express the confidence interval 24.2% to 42% in the form of p hat plus the margin of error. So the first thing I'm going to do is find p hat. So in order to find p hat, I'm going to take the two values in our confidence interval. I'm going to add them up and divide by 2, right? Because that would give us the number that's directly in the center of this confidence interval. So here we're going to keep the percent symbols because they want the answer in percents. So to find p hat is going to equal to 0.24% plus 42% divided by 2. Excuse me, that's 24.2%. 24.2% plus 42%. So I'm going to use a set of parentheses for the numerator. 24.2 plus 42. I'm going to close off my numerator. I'm going to divide by 2. And we have 33.1% as p hat. All right. So next we're going to find the margin of error. So how will I find the margin of error? Well, from our confidence interval, right, p hat minus e and p hat plus e. So I can take my p hat value and I can either add it or subtract it from one of the ends of my confidence interval. So there's like a couple of ways I can do this. So the margin of error is going to equal to 33.1% minus 24.2%, right? Because 33.1 is exactly in the middle. So if I either add or subtract my endpoints, that'll give me that margin of error. Or I could even do it this way. I can take 42% and I can subtract 33.1%. So you don't have to do them both ways. I just want to show you that you can either use the lower end of your confidence interval or you can use the upper end. But either way, you should get the same value. So if we were to calculate this 33.1 minus 24.2, you get 8.9%. Or I could subtract the upper part of our interval from the p-hat value, and you still get 8.9. So you don't have to calculate it both ways. All right, but just to show you, you can use either end of your confidence interval. So we should have p-hat is 33.1, and the margin of error is 8.9. Okay, now let's just take a look at a straightforward example, just where you can just stick everything in the calculator. So this is like number 6. It says in a recent poll, 510 people were asked if they like dogs. 45% said that they did. Find the margin of error for this poll at the 90% confidence level. So I'm basically going to use that one proportion Z interval. So I'm going to go into stat. I'm going to scroll over to test. I'm going to scroll down to one proportion Z interval. I'm going to put in X. I have to put in N. So I know N is what, 510? I know that the confidence level is 90%, which is 0.9. How would I find X? And this is where some of that algebra stuff probably comes in. So to find X, so let me just copy this so I can write on it. This was number 6. So that was equal to Z alpha over 2 times the square root of P hat times Q hat divided by N. All right. So I thought this was asking for a confidence interval, but it's just asking for the margin of error only. So that's the formula for the margin of error. So Z alpha over 2 is, for a 90% confidence level, Z alpha over 2 is 1.645. Let me just make sure. Yeah, 1.645. P hat is 0.45, right? Because it says 45% said that they like dogs. Q hat is 0.55, right? Because Q hat is 1 minus P hat. And then N is 510. So if I plug all of this in, we have 1.645 times the square root of 0.45 times 0.55 divided by 510. So 1.645 times the square root of 0.45 times 0.55 divided by 510, and we get 0.036.